Hello, fourth graders. Welcome to lesson 5.5. Today, we are going to be doing something a little different today. How about this question? If I have 6 apples and I get 3 oranges, how many bananas do I have? And you're probably thinking to yourself, what in the world, Mr. White? What are you talking about? We can't add apples plus oranges and get an answer of bananas. We either have to add all apples or all oranges. All right, don't forget that here. Let's go into the math message. So, Eric made a poster with 100 paper clips for the 100th day of school celebration. 2/10 of the paper clips were gold. 45 hundredths of the paper clips were silver. The rest were other colors. On your dry erase board or on a piece of paper is fine. Write a number model with an unknown to represent the fraction of paper clips on Eric's poster that are silver or gold. All right, let's do this together. If we had we know that 2/10 are gold. And we know that 45 hundredths, we're going to add these together because we want to know how many are silver or gold, right? The total plus 45 100ths equals our answer, right? Equals, we'll say C for clips. Now, we now have to deal with this because wait a minute, every time we've added fractions so far, we've always kept the bottom number the same. But what do? I have 10 and I have 100. I can't add these. I'm going to tell you that right off the bat. Some people think, oh, here we go. We'll add the tops and we'll add the bottoms. Okay, but that will not work. And I'll show you why here in just a second. Let's get rid of that though. Actually, let's look at y right now. This is a good time to do that. Let's say you had some fractions that you know really well, right? Like 1/2 plus 1/4. Okay, you know that this is going to equal more than half of a circle, right? If you have 1/2 of a circle and you have 1/4 of a circle, that's going to equal more than half. But watch, if I use that strategy, add the bottoms and add the tops, look at this mess. Now I have 2/6, an answer that's less than half. So you do not add the bottom numbers. You do not add, remember that, never, ever, 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 never, never add the denominators. What we are going to do instead is, well, what do you think we could do? Do you have an idea? All right, I'm going to tell you. We're going to think about how we could change 2/10 into hundredths, right? 2/10 into hundredths. And if you think about a grid, right? A number grid that we've seen, 2/10 was 1, 2. How many, if that grid had 100 on it, how many hundredths would those 2/10 have been? It would be 20, right? It's just like if you had these 2 long base 10 blocks and you broke them into all of those little pieces. So 2/10 and 20 hundredths are equivalent fractions. We can test that out by using multiplying, right? We have 2 times 10 equals 20, and 2 times 10, 10 times 10 equals 100. So we are going to take out the 2/10 and replace it with 20 hundredths. We didn't change the value at all, did we? We kept it exactly the same. But now look what we have. We have 2 denominators that are the same. So I can keep those the same, and I can add 20 plus 45 and get 65 hundredths. So you either have to have all apples or all oranges. You cannot add apples plus oranges with our fractions here. All right. That's kind of, that's the same one as we did. So today we're learning strategies for adding fractions with unlike denominators. And you see that this is actually a 5th grade standard that we introduce here just a little bit in 4th grade. So we did that. Let's look at this one. Here we have 6/10 plus 3/100. Well, 6/10 is the same as 60/100. So now I made the denominators match, right? I can add them once the denominators match and get 63/100. Okay, once you have the hang of this, I think that you'll got it, that you'll do pretty well here. All right, 5/10. How many hundredths? What could we make this? How many hundredths? 50/100 plus 41/100. And what's the answer here? It is 91/100. See, we can't add apples plus oranges, but we can add apples plus apples. All right. Whoa, look at all of this. Well, let's see. This one's hundreds and this one's hundreds, so we're just going to keep those the same. 2/10. How many hundredths would that be? What would be equivalent? 20/100. And then this is a weird one, right? 15/10. So this is an improper fraction, right? Remember when we were using multiplying, we could do, right? 15 over 10 equals how many hundredths? Well, 10 times 10 equals 100, and 15 times 10 equals 150. So this is actually 150 over 100. Hey, if I add all of that up, let's see, that's 150, 170, 201, 210. 210 over 100. And if you want to put that as a mixed number, 210 over 100, well, 100 out of 100 would be one whole, 200 out of 100 would be two wholes, and then 10 hundredths left over, or 2 1/10. Okay, any of these three answers, I would, right now I'm going to count as correct. This is the mixed number. This is what's called a reduced mixed number. All right, let's see. Let's do one with mixed numbers here. If we have 2 1/10, 9 and 2500. So we don't have to do anything with the whole numbers, okay? But we do need to do something with this 1/10. What do we need to do to it? Change it to 10 hundredths. Okay, 2 and 10 hundredths plus 9 and 25 hundredths. What would that answer be? Did you say 11 and 35 hundredths? If you did, you're correct. All right, so that's the goal today, is to be able to add fractions with different denominators, right? So now the denominators are different, and we have to fix it so that they are the same. All right, your math journal page here is page 164. This says try this. That means yes, you do the problem. It doesn't say try this if you want to, right? So we're going to do all of the problems here on this page. And if you need to look back at the video, just remember you can't add apples plus oranges and say the answer is bananas. You either need all apples or all oranges. So figure out ways to make those denominators match. All right, if you need help with anything, please reach out and let me know. And good luck.